Black holes have an opposite. They're called white holes, objects from which everything comes out and nothing can enter. The idea of white holes did not come from movies. It came from Einstein's equations. In 1916, Carl Schwarzschild found the first exact solution to Einstein's equations for the gravity of a point mass. If you take the solution for a black hole and mathematically reverse the direction of time, you get an object with opposite properties. A black hole lets everything in but nothing out. A white hole lets everything out, but nothing in. From the perspective of the equations, a white hole is a perfectly valid solution. In early models of general relativity, black holes and white holes were even connected by the Einstein-Rosen bridge, a type of wormhole. In these early models, one side was a black hole, the other a white hole, forming a theoretical tunnel through space-time. The first major problem is thermodynamics. A white hole violates the second law of thermodynamics because matter comes out without a past. In our universe, entropy, the measure of disorder, never decreases on its own. Order naturally turns into chaos. A glass can shatter, but the pieces never assemble themselves back into a whole glass. The second problem is instability. Even a single particle entering the entrance of a white hole destroys the mathematical solution. A white hole is not really an object. It is a state. A black hole is stable. A white hole is extremely fragile. It can exist only under perfect conditions. Nothing enters, everything exits, and time behaves as if it were running backward. Imagine a video where shattered glass reassembles itself perfectly. Such a process is possible only if nothing interferes, no noise exists, and no new object appears in the frame. A white hole is exactly such a reverse process. But if even a single grain of sand appears, the scenario breaks. The conditions change, and the solution is no longer the same. Some modern theories suggest that a black hole might slowly transition into a white hole-like state due to quantum effects. But this would take timescales billions of times longer than the age of the universe. White holes exist in mathematics. In theory, they are possible. But in the observable universe, we have no evidence that they exist. If black holes have an opposite, why have we never seen it? Perhaps because not everything allowed by mathematics is allowed by the universe.